Yes, sir. Sir, వినిపిస్తుందా?
ఓకే మేడం, మీరు మీకు లైవ్ ఇచ్చేసాను, మీకు హోస్ట్ ఇచ్చేసాను, మీరు మీటింగ్ ఎండ్ చేయండి. ఓకే, లైవ్ ఇచ్చా. ఓకే, స్టార్ట్ ద క్లాస్ మేడం.
ఓకే సార్. Good morning, children. Welcome to the Maths webinar classes conducted by Christ Society. Subject match to be topic parabola. Today, we are going to learn the concept focal distance in the chapter parabola. Focal distance. Let us see the definition, children. The distance of a point on the parabola from its focus is called the focal distance. From its focus, children. Look at a point. Look at the point P, children, on the parabola. And we have a point S, which is focus of the parabola. So the distance between these 2 points, SP, is called the focal distance of a point on the focal distance. So from the figure, focal distance is SP. The distance of any point on the parabola from its focus is called focal distance. From the figure, focal distance is SP. Focal distance of a point P with respect to the parabola y square equal to 4ax is shown in the figure, children, when the parabola is in standard form. So the focal distance of P is equal to SP. When P lies on the parabola, we have SP is equal to PM, the perpendicular distance of the point from the directrix is PM. So SP is equal to PM. Observe the figure, children. PM is equal to NZ. PM is equal to NZ. We are transforming the unknown distance to known distance on the x-axis. NZ can be split into sum of the 2 distances, known distances. That is, NZ is equal to NA plus AZ. NA plus AZ. What is NA, children? X1. What is AZ, children? A. Therefore, focal distance of P is equal to x1 plus A. The focal distance of a point P, x1, y1, with respect to the parabola y square equal to 4ax is x1 plus A. Is this clear, children? Let us solve a problem depending upon the concept. Find the coordinates of the point on the parabola y square is equal to 8x, whose focal distance is 10. Look at the figure carefully, children. Take the parabola y square is equal to 8x. And the focal distance is nothing but the distance of the point on the parabola from the focus of the given parabola, SP. Comparing the given parabola y square equal to 8x with the standard form y square equal to 4ax. 4a is equal to 8, from which a is equal to 2. Therefore, focus SA comma 0 is S2 comma 0. Given that focal distance SP is equal to 10. Let us write the solution, children. Given parabola, y square is equal to 8x. Comparing with the standard form, 4a is equal to 8, from which a is equal to 2. Therefore, the focus of the parabola y square equal to 8x is SA comma 0 is equal to S2 comma 0. Let Px comma y be a point on the parabola whose focal distance is 10. So given SP is equal to 10. What is the focal distance formula, children? From the previous explanation, we understood that focal distance is equal to x plus a equal to 10. So x plus, substitute the value of a, which is 2. Actually, the focal distance is x plus a is equal to 10 is a distance in the mode. So focal distance x plus 2 is equal to, can be plus 2 or minus 2. So absolute distance. Here, I could not mention the modulus, children. So it is mod x plus 2. When we remove mod, the value will be equal to plus or minus. So mod x plus a equal to 10, x plus a equal to plus or minus 10. So we have a point here, SP, whose focal distance is equal to 10. So the condition satisfied by the point is x is equal to 8 or x is equal to minus 12. Now substituting these values, x is equal to 8 in y square equal to 8x, we shall get the value of y, from which we get the coordinates of the point, children. Substitute x equal to minus 12, y square will be negative, which cannot be taken in this case. So substitute x equal to 8 in y square equal to 8x. Then y square is equal to 8 into 8. Y square is equal to 64. So y is equal to plus or minus under root 64. So y equal to plus or minus 8. Therefore 8 comma 8 and 8 comma minus 8 are the two values which need to be remembered. So hope you can understand and continue the solution. X equal to minus 12 is not giving the y coordinate because substituting x equal to minus 12, y square is negative. So I'm going to the next problem, children. Here you need to continue the solution. The slide was deleted by mistake, so could not continue here. Substitute x equal to 8 here so that you will get two y values. Corresponding to x equal to 8, there are two y values, plus or minus 8. Therefore, coordinates in this case are 8 comma plus 8 and 8 comma minus 8. Now, let us solve another problem. Find the coordinates of the points on the parabola y square equal to 2x, whose focal distance is 5 by 2. It's same as previous problem, children. Let px comma y be a point on the parabola y square is equal to 2x. How can we solve, children? Whose focal distance is 5 by 2. Now we are choosing a point px comma y such that the focal distance is 5 by 2. Compare this y square is equal to 2x with the standard form y square equal to 4ax. We shall get the focal distance of the point x plus a is equal to 5 by 2. Now, what is a, children? 4a is equal to 2. Comparing that with the standard form, 4a is equal to 2. Comparing the given parabola with y square equal to 4ax. We'll get 4a is equal to 2, from which a is equal to 1 by 2. Substituting that value, a is equal to 1 by 2. Actually, the focal distance should be in mod, children. It's just printing mistake here. So x plus 1 by 2 is equal to 5 by 2. We will take positive values only. Though it is mod, we will take positive values only. Negative value cannot be taken. Because if this focal distance is negative, focal distance is always positive. Focal distance is a distance. So it should always give us the positive value. Though it is mod, we take only positive value here. Is it clear, children? We don't take negative value. So focal distance x plus 1 by 2 is equal to 5 by 2. It is given. Substituted a value, from which x is equal to 5 by 2 minus 1 by 2. So x is equal to 4 by 2, from which x is equal to 2. Substituting this x is equal to 2 in y square equal to 2x in order to obtain the y coordinate. So y square equal to 4. So y is equal to plus or minus 2. Y is equal to plus or minus 2. So x equal to 2 comma plus 2 and x is equal to 2 and y equal to minus 2 gives us two coordinates on the parabola whose focal distance will be 5 by 2. So the required points is when x equal to 2, case 1, y equal to 2. So 2 comma 2. When x equal to 2 and y equal to minus 2, it is 2 comma minus 2. Is this clear, children? I repeat the concept here. X plus a is equal to 5 by 2. You need not keep mod also. Because we take positive values. It doesn't require mod. Okay. No need to keep mod. X plus a is equal to 5 by 2. And substituting a is equal to 1 by 2 from the standard form. X is equal to 2. Substituting x equal to 2 in the standard form of the parabola, in the given form of the parabola y square equal to 2x, we get two values for y plus or minus 2. So the required points are 2 comma 2 and 2 comma minus 2. Hope this is clear, children. Now, parabola and a point in the plane of the parabola. Let us take a parabola, children. And the points on the parabola, which satisfies the condition SP is equal to PM, are said to be a point on the parabola. And points like focus are said to be a points in the interior plane of the parabola. The points which are not in interior of the parabola or on the parabola and outside the branches of the parabola are called the points in the exterior plane of the parabola. You can look at the diagram, children. It is the exterior side of the parabola. And this is the interior of the parabola. And the curve, the points on this curve are said to be points on the parabola. Therefore, the curved parabola divides the plane into three mutually disjoint sets. One, the points in the interior plane of the parabola, the points on the parabola, and the points in the exterior plane of the parabola. Now, the point, the plane which contains the focus is called interior of the parabola and the other is called exterior of the parabola. Note, let Px1, y1 be a point and s is equal to y square minus 4x equal to 0 be a parabola. Then, when do we say that P lies on the parabola, children? When s11 equal to 0. And when s11 equal to 0, the point P lies on the parabola is implies an implies condition. When P lies inside the parabola, implies and implies s11 is less than 0. It's as same as the cases we have learned in the chapter circles, children. When P lies outside the parabola, implies and implies s11 is greater than 0. If P lies on the parabola, s11 is equal to 0. When P lies inside the parabola, s11 is less than 0. When P lies outside the parabola, s11 is greater than 0. Same like circles. Let us solve some problems depending upon the cases, whether the point lies on inside the parabola or on the parabola or outside the parabola. Dear children, let us read the question. Find the position of the following points with respect to the parabola y square equal to 6x. Position in the sense whether the given points are interior or exterior or on with respect to the given parabola y square equal to 6x. The first point is 6 comma minus 6. Let us take the equation of parabola, children. Y square equal to 6x. Bring 6x to the left hand side. Transforming 6x to the left hand side with respect to addition, we shall get s is equal to y square minus 6x. Now, consider the point 6 comma minus 6 and write s11 for the parabola s is equal to y square minus 6x. Y is minus 6. So, wherever there is y, substitute minus 6. And wherever there is x, substitute 6. Same like circles. So, it is 36 minus 36 is equal to 0. It is minus 6, but it is squared, children. So, it is plus 36. 36 minus 36 is equal to 0. S11 is equal to 0 implies the point 6 comma minus 6 lies on the parabola. Y square equal to 6x. Now, let us take the points 0 comma 1 and calculate S11, children. S11 is for the given parabola y square minus 6x. Y is 1. So 1 square minus 6 into 0. So it is 1. S11 is 1, which is greater than 0. Therefore, the point 0 comma 1 lies outside the given parabola y square equal to 6x. When S11 is greater than 0, the point lies outside the parabola. Let us take the point 2 comma 3, children. Find S11. Y is 3, so y square, 3 square minus 6x. So 9 minus 12, which is minus 3. So S11 is a value which is less than 0. Therefore, the point 2 comma 3 lies inside the parabola. So, in coming exercises, we use the following notations in that to be noted, children. As we have studied in the equation of a circle, we also study the values of S1, S11, S12, what they mean in the chapter. So let us recapitulate the notations again, children. We know S will be the general form of the curve. So since we are talking about the parabola in this chapter, S is y square minus 4ax. S1 is y1 minus 4a can be split as minus 2a times x plus x1. S11, both x1, y1 should be replaced. So it is y1 square minus 4ax1. S12 is x is substituted with 1, s suffix will be substituted with 1, and y suffix will be substituted with 2. So this is y square will be given as y1, y2 minus 2a times x1 plus x2. Here, x1, y1 and x2, y2 are the points in the plane of the parabola. Y square equal to 4ax is to be noted. Now, we shall find the equation of the parabola. We shall find the equation of the parabola passing through the points minus 1, 2, 1, minus 1 and 2, 1 and having its axis parallel to x-axis. Observe that, children, there are 3 points on the 3 points on the parabola are given. The other important condition is axis of parabola is parallel to x-axis. Axis of parabola is parallel to x-axis. When axis is parallel to x-axis, how will be the figure, children? So it is a rough sketch. It can also open on the other side. So this is origin and this is x-axis. Okay, it can also be open like this. It's a rough sketch, children, just to remind you how the equation will be, how the geometric structure will be. Solution. Equation of the parabola whose axis is parallel to x-axis will take the form x equal to ly square plus my plus n is a formula, children. What is the formula? The equation of the parabola, we have different forms in the parabola. On expansion, it takes the form x equal to ly square plus my plus n or y is equal to lx square plus mx plus n when the axis is parallel to either x-axis or y-axis. Okay, children, that was discussed in our last class. When axis is parallel to x-axis, what is the formula, children, for to find the equation of the parabola? When parallel to x-axis, it starts with x and is a second degree in y. So x equal to ly square plus my plus n. Now, this parabola is passing through these 3 points. Just substitute these 3 points in equation 1, same. I have written in a simple way in the PPT, but you have to write a minus 1, 2 lies on parabola. Therefore, substitute the point, children, minus 1, 2. In x place, we have to substitute 2. In y place, in x place, we have to substitute minus 1. In y place, we have to substitute 2. Therefore, it is minus 1 equal to L into 2 square plus m into 2 plus n. Simplify and arrange them in order of L, m, n in right hand side and left hand side constant. This is all about the first point a minus 1, 2. Similarly, we shall also get the second point, B 1 comma minus 1. Where will be the point B 1 comma minus 1 is on the parabola. That should be written, children, here. B 1 comma minus 1 lies on the parabola x equal to ly square plus my plus n equal to 0 should be written. Sorry, x equal to ly square plus my plus n should be written. Substitute the point, children. Wherever there is x, substitute 1. Wherever there is y, substitute minus 1. And arrange right hand side with element terms and left hand side with the constant. After simplification, let that be equation 3. Now, we also have another point C2, comma 1 on the parabola. Now, let us substitute the point C2, comma 1 on the parabola. So, in place of x, we have to substitute 2. In place of y, we have to substitute 1. Then, it is 2 is equal to L into 1 square plus M into 1 plus N. Is this clear, children? On simplification, we shall get 2 is equal to L plus M plus N. Now we have to solve the equations 2, 3, 4, taking 2 at a time and find the values of L, M, N. Now, solving 2 and 3. Hope you know the method of solving, children. When we have the same coefficients, same values, n and n in both the equations, we simply subtract. That we have also observed in the chapter circles. Solving 2 and 3, we get equation 5 in terms of only L and M because n will be removed when we subtract. Similarly, solve 3 and 4. What shall we do? We subtract equation 4 from 3 so that n and n will be cancelled. And we shall get only equation in terms of M and L. Here, L also got cancelled, so we got the directly M. Otherwise, we shall get another equation in terms of M and L. Now, we got the value of M as 1 by 2, children. Substituting M is equal to 1 by 2 in equation 5, we will get L. Substituting that L in one of the equation involving N, we shall get LMN values. So, this L value is substituted in an equation where there is N children. So, we will get N equal to 8 by 3. Like this, we will get L value, M value, and N value. When we substitute LMN here in the supposed equation of the parabola, we shall get the required equation of the parabola. In this case, the required equation of the parabola is 7y square plus 6x minus 3y minus 16 equal to 0. Hope the concept is clear for you all, children. I recapitulate the problem. We have 3 points on the parabola. X equal to Ly square plus My plus N. Why did we choose this form, children? We have chosen this form because in the question it is given that the axis of the required parabola is parallel to x-axis. And substituted the points one after the other and solve their simultaneous equations to find the values of unknowns L, M, N. After solving, we get LMN values. Substituting those values in the equation x equal to Ly square plus My plus N, we got the equation of the required parabola as 7y square plus 6x minus 3y minus 16 equal to 0. Now, the same kind of the question, but the axis is parallel to y-axis is the concept, children. Let us read the question thoroughly. Find the equation of the parabola whose axis is parallel to y-axis and which passes through the points 4, 5, minus 2, 11 and minus 4, 21. Now, axis will be parallel to y-axis. That should be remembered, children. Given that the axis of the parabola, axis of the required parabola is parallel to x-axis. Therefore, equation of the required parabola will be in the form y is equal to lx square plus mx plus n. Let it be equation 1, children. And this parabola passes through this given 3 points. 4, 5, minus 2, 11, and minus 4, 21. Isn't it, children? Now what shall we do? We shall substitute the points, the 3 points, one after the other in the equation of the parabola, in the supposed equation of the parabola. First, we shall substitute the point 4, 5. We get Lx square plus mx plus n is equal to y. This is the parabola when passing through the point 4, 5. So x is 4 and y is 5. So if the parabola is parallel to, if the axis of the parabola is parallel to y-axis, its equation starts with y, children. Y is equal to, see, y is equal to lx square plus mx plus n. On simplification and rearranging the terms in the form of LMN, we get 16L plus 4M plus N is equal to 5. It's equation 2. Now, let us substitute that second point on the parabola. What is the second point, children? Minus 2, 11. It is L into minus 2 of whole square plus M into minus 2 plus N is equal to 11. So 4L minus 2M plus N is equal to 11 is equation 3. Similarly, let us substitute the last 2 point minus 4, 21 on the parabola and get the equation in terms of LMN. Then it is 16L minus 4M plus N is equal to 21. As time is limited, I am unable to spend much time on expanding the squares, multiplying with minus, and all this simple calculations, children. I am stressing much on the concepts. Our parabola, Lx square plus mx plus n equal to y is passing through 4, 5 gives us equation 2. Our parabola in equation 1 passing through minus 2, 11 gives us equation 3. Our parabola passing through minus 4, 21 gives us equation 4. So 3 points, we get 3 equations. Solving these 3 equations, taking 2 at a time, we get, look at the question, look at the equations, children. In both the equations, we have n same. So when we subtract, we shall get an equation involving L and M. We have taken 2 and 3 in the beginning, and next we shall take 2 and 4. Now again 2 and 2 gets cancelled. Luckily here we also have M and M gets cancelled. So we got directly value of M as minus 2. If we substitute this M in the equation 5, we will get the value of L as 1 by 2. So we got L and M. Substitute this L and M values in any of the equations involving N. For example, substituting in equation 3. We had to check whose coefficients are small. In that equation, if we substitute, we will get the answer soon. Instead of substituting in the equation whose coefficients are big. Then we get N is equal to 5. So we got L value, M value, and N value. Where shall we substitute these LMN values, children? In the supposed equation of the parabola, y is equal to Lx square plus mx plus n. Then we get the required equation of the parabola as x square minus 4x minus 2y minus plus 10 is equal to 0. Hope you are clear with the concept, children. Please do practice to understand better. Now this is your assignment, children. Find the equation of the parabola whose axis is parallel to x-axis and which passes through the points minus 2, 1, 1, 2 and minus 1, 3. Axis is parallel to x-axis. Therefore, hint. The required equation of the parabola will be of the form x equal to ly square plus my plus n. With this, our class 4 ends, children. Have a great day, all. Stay home, stay safe. Have a happy learning, children.